Session 9 Electronic Communication Radio Waves. Basically, we are going to discuss how the waves are transmitted from transmitting station to receiving station. Brief history of radio waves. We receive transmitted radio waves for enjoyment, entertainment, and information purpose. Information may be in various forms. The visible spectrum forms a very small region in the entire spectrum of electromagnetic radiations. As energy increases along this particular region, as the frequency increases, at the same time wavelength decreases. In the year 1900, first wireless message was transmitted, where the receiving and transmitting stations are hardly 1 mile apart. Prerequisites for electromagnetism. Electricity and magnetism are two faces of same forces. Recall or previous understanding. Static distribution of charges produces an electric field, and the charges in motion will constitute an electric current. Whenever there is electric current, it is always followed by certain magnetic field. So surrounding this current carrying conductor, we are going to have a magnetic field. If we move the magnet to and fro, electric current will flow in this coil. Hence, both electric and magnetic field produces a force on charges. An accelerating charge produces electromagnetic waves or electromagnetic radiations. Electric field energy used in electric circuit and released in lightning. Magnetic field carries energy through transformer. Electromagnetic waves are traveling with the velocity of light in vacuum, that is some 3 into 10 to the power 8 meter per second. Examples of electromagnetic radiations are AM and FM radio waves, including TV signals, Seinfeld convection, microwave, infrared radiation, light, X-rays, gamma rays. The frequency and wavelength are related by the relation F into lambda is equal to C, where F is the frequency, lambda is the wavelength of the wave, and C will be the velocity of light. The waves will travel. If observe the electromagnetic spectrum, the gamma rays and X-rays will have very high energy as their frequency is very large and their wavelength is smaller. As compared to the radio waves will have a very wide spectrum ranging from several meters to several kilometers. The things to remember regarding electromagnetic waves are: higher the frequency, more energy of the wave has. Electromagnetic waves do not require media in which to travel or move. Electromagnetic waves are considered to be transfer waves because they are made up of vibrating electric and magnetic fields at right angles to each other and to the direction of waves are traveling. The relation between them, F, is inversely proportional to wavelength, that is, wavelength gets smaller, frequency gets higher. The waves, especially radio waves, longest wavelength and lowest frequencies. They ranges from thousands of meters to 0.001 meter. Radio waves are used in radar, cooking, food, satellite transmission, etc. In this topic, we are going to cover radio waves, space communication, types of radio waves propagation, ground wave propagation, sky wave propagation, space wave propagation, radio waves propagation, and we are going to define critical frequency, critical angle, MEF, virtual height, second law. Regarding space communication means free space communication. Free space does not have any solid particles or ionized particles, and it has no gravitational or other field of its own. When the frequency of transmitted wave is very high, the actual space is considered nearly a free space. Next, propagation of electromagnetic waves. Depending upon the frequency, radio waves travel in space in different ways. Depending upon the behavior of these waves with respect to Earth and atmosphere, the radio waves are classified as ground wave propagation, sky wave propagation, and space wave propagation. This is ground wave or surface wave propagation, sky wave propagation, space wave propagation. These propagations are also referred as space wave propagation, sky wave propagation, or tropospheric wave propagation. So surrounding the Earth, we have different layers. The layer in which we live is called troposphere layer. Next comes stratosphere, mesosphere, ionosphere. Further, they are classified as tropopause, ozone layer, mesosphere, and ionosphere. One can further classify this ionosphere as D region, E region, F1 and F2 region. During night time, only E and F region we will see. We are going to discuss these things in detail later. First, ground wave propagation. Amplitude modulated waves are used for this propagation. In ground wave propagation, the radio waves, amplitude modulated, travel along the surface of the Earth. These waves are called ground waves or surface waves. In fact, these waves are not confined to the surface of the Earth, but they are guided along the Earth's surface and they follow the curvature of the Earth. Now, the energy of radio waves decreases as they travel over the surface of the Earth due to conductivity and permittivity called attenuation. The attenuation of wave increases with increasing the frequency. So because of this reason, the ground waves are limited to the frequency 1.5 MHz or the wavelength approximately 200 meters. Ground waves propagate along the surface of the Earth and must be vertically polarized to prevent from short-circuiting the electric components. A wave induces current in the Earth over which it passes and thus loses some of its energy by absorption. This is made up by energy diffracted downwards from the upper portion of the wavefront. Another way of attenuation is due to diffraction and gradual tilting of the wavefront. The increasing tilt of the wavefront causes great short circuit of electric field components of the wave. The increasing tilt of the wavefront causes great short circuiting of electric field component of the wave. Eventually, at some distance from the antenna, the wave will dies down and dies. The maximum range of transmission depends upon its frequency as well as power. Next, skywave propagation or ionospheric wave propagation. The skywave are the amplitude radio waves which are received after being reflected from ionosphere. The propagation of a radio wave signal from one point to another point via reflection from ionosphere is known as skywave propagation. This is skywave propagation. The skywave propagation is a consequence of total internal reflection of radio waves. Higher we go in the atmosphere, electron density increases and the refractive index decreases. The ultraviolet and high energy radiation from the sun are absorbed by the air molecules and they get ionized to form the ionized layer or electrons and ions. Ionosphere extends from 80 km to several kilometers, more than 300 kilometers in the atmosphere above the Earth's surface. During daytime, the ultraviolet rays and energetic rays which are coming from the sun, they will interact with the air molecules and ionize the air particles which are present in this particular region, producing more number of layers, D layer, F layer and F1, F2 layers. But during night time, since the ultraviolet rays and high energetic rays are lower, hence the D layer and F1, F2 merges to form only two different layers, E layer and F layer. The oscillating electric field of electromagnetic waves frequency omega does not affect the velocity of ions. Negligible changes because the electromagnetic wave field is weak in the ionosphere but changes the velocity of ions. This changes the effective dielectric constant epsilon r and hence the refractive index eta dash as compared to free space dielectric constant and refractive index. The dielectric constant and refractive index are related by the free space dielectric constant and refractive index by the formula eta dash is equal to under square root epsilon dash n naught, or eta dash will be given by this particular expression. Here we can see that the value of this eta dash will depend upon the value of n and omega. From this we can conclude that the refractive index of ionosphere is less than the refractive index of free space, as a result of which the ionosphere acts as a rarer medium. Therefore, for the angle of incidence above the critical angle, the electromagnetic waves undergo total internal reflection and reaches back to the Earth, as in case of air and water. This is denser medium and this is rarer medium. Above the critical angle, the rays will be reflected back in the denser medium only. The critical frequency is the highest frequency for a given ionospheric layer that can be written down to the Earth by the layer after having been beamed straight upon it. When we incident electromagnetic radiation with a particular frequency, if the frequency increases, the wave will travel much deeper and deeper into the ionospheric region and they may be reflected back from that particular region, provided the electron density in that region is more than sufficient to reflect back. If the frequency is too high, then the ionospheric layer may not be able to reflect these rays backwards to the Earth. Since the refractive index of ionospheric layer depends upon the frequency and the number of concentration of ions in that particular layer, as we incident the rays with higher frequency and less angle of incidence. If the frequency omega is too high, then the electron density n may not be so high to produce total internal reflection. This frequency is called critical frequency. If the maximum electron density of ionosphere is n maximum per meter cube, then the critical frequency is given by the relation Fc is equal to 9 n maximum over the square root. Next, space wave propagation. The space wave follow two distinct paths from the transmitting antenna to the receiving antenna. One through air directly to the receiving antenna, another through reflected from the ground surface. If the transmitted antenna is at height HT and the receiving antenna is of height HR, then the distance of maximum line of sight, this distance DM is called line of sight distance, will be given by this particular relation. Satellite communication. The microwaves carrying audio, video, telephone, telefax signals are transmitted from the Earth to the satellite orbiting in the space and retransmitted from the satellite to different part of the Earth. Similarly to line of sight microwave transmission, satellite act as a super tall antenna and repeaters. Satellite communication is mainly done through geostationary satellite. Three geostationary satellites placed in equatorial orbit at 120 degrees from each other can cover practically the whole populated land area of the world. Frequency modulation is used for both up channel and down channel. Though frequency modulation needs a larger bandwidth, it offers good immunity from interference and requires less power in satellite transmitter.